Hey everyone, this video is what is Benthos? I'm Ash and I'm a good person to ask because I made it. So the first thing is it's got a great mascot. It's an open source project, it's MIT licensed, so you can do whatever you want with it, and as you can see it's very active. It's got a great community. As far as communities go, it's significantly gooder than the Star Wars fan base, but not quite at the strength of the Beliebers out there, so maybe we'll get there one day, but not quite yet. And what it is it's a streaming service, so you can deploy this and it will consume from one or more streaming sources of data, and it can do a bunch of different things to that data, but it's usually transformations like single message transforms, so mapping and schema validation stuff, and then filtering, and then it can also do stuff like hydration and enrichments by interacting with other services, things like caches and databases, serverless functions and HTTP servers and things. And then finally it writes that stream of data out to one or more sinks, following a brokering pattern of your choice. You could call this a streaming ETL service. It's kind of in the sort of data engineering-y space, so it's often used for things like ETL pipelines. You could call it ETLT, use it for that as well, for either of those T's, if you're a bit more with it. But its core functionality, the main defining feature of Benthos as a project is that it's boring. So it's ready to deploy as a static binary. It's got no runtime dependencies. It uses a declarative configuration, which I'll go into in a minute, which means you don't have to compile or build anything yourself unless you want to. It's totally stateless, so it can do stateful things by interacting with other services. But Benthos itself is totally stateless, so you can horizontally scale it just by deploying more of them, and you can kill them and switch them off at a whim. You can really punish them, and there's no real repercussions to that. It's totally payload agnostic, so usually you'd use it to process structured data, things like JSON documents or Avro or whatever, but you can also just pass through binary data if that's what you want to process. It's got no opinions as to what data should look like that it works with, and it's got a bunch of observability stuff out of the box, so it's got logs, metrics, tracing, and the metrics that it exposes you can export via Prometheus or StatsD, InfluxDB, a bunch of other options. And this is what the configuration looks like. So imagine we've got a hypothetical pipeline we want to set up where we're reading events from Google PubSub, for example, and then maybe we'll do a bit of mapping to the structured documents coming through, and then finally we might want to write that out to Redis streams, something like that. This is what the config might look like. So you've got an input section where you describe where the data is coming from. You've got a pipeline processor section where you can specify any number of these processes that will be executed in the order that you list them. So this one's a little mapping that we've got. And then finally you specify where the data is going to. And that's it. So that's all that you really need to specify in a config. And the things that you don't need to specify and is handled for you is stuff like how to manage retries, acknowledgements, delivery guarantees, back pressure, all that nasty stuff. And the massive advantage of the declarative configuration is that as your requirements change, you just have to make small modifications to your declarative config. So for example, if we wanted to add another output, and perhaps route messages to a particular output based on its contents, well then we might just need to do some minor changes like this, where what I've done is I've replaced my output with a switch type, which is a broker, and it has one or more children. And what I've done is I've moved my Redis output to be one of these children, and then I've added another output, which is Amazon SQS in this case. And then what I can do is I can specify some conditions to check on the messages to determine which of the outputs it's going to go to. So it's quite a significant change to the pipeline in terms of what it's doing as a service, but the config hasn't really had to change that much. Similarly, we might want to do stuff like add more processing steps. So what I've done here is in my little architecture, I've added in a Lambda function invocation. So what's going to happen is we do a bit of mapping to the messages, and then all I've had to do is add 2 lines of config, and now that message is going to get sent to a Lambda function. We're going to invoke it with the message contents, and then whatever comes back is going to replace the message before it gets sent to our output. Now, normally with enrichments, you wouldn't want to do that. You wouldn't want to just send the entire existing message out to that enrichment service, you'd want to send some sort of like mask or modification to it, or a subset of the message. And similarly, when whatever comes back, you probably wouldn't just want to replace the message entirely with the result. You'd want to map the result back into the message. So Benthos has got loads of tooling for doing stuff like that because it's kind of its bread and butter. So what we can do with our config is put our enrichment within what's called a branch processor, which has any number of child processors. But the difference here is you specify a request map, which takes the message as it currently is and modifies it into something that we want to send to our enrichment services. Then we invoke our enrichment processors. And then finally, we have a result map, which describes how to take the result of the enrichment service and map it back into the original message. So what we're doing here is we're just putting it into the path meta.sentiment, because this was some sort of sentiment analysis. And that's pretty much it. To install it, as you might imagine, is also pretty simple. So with Homebrew, for example, you just grab a binary, and then you can also use that binary to generate configs. So there's a create sub command, and you can specify the components that you want, and then just pipe that into a file. And then similarly to run it, you just point it to that config, and it will start running the config. Obviously, if you're gullible, you just want to run some bash off the internet, then you can do that as well. And I would say most people who are going to deploy Benthos are going to do it with Docker, so that might be how you choose to install it, and that's just as easy. The other core defining feature of Benthos is that it's safe. So this is primarily a data engineering tool. It looks very similar to some observability tools, things like Logstash and stuff, but its primary purpose is for data engineering tasks. So the way that it treats data by default is much more in line with strong delivery guarantees and not just dropping data because we couldn't do anything with it. So the way that it works architecturally, I'll show you that in a second, but it works with transactions. So Benthos doesn't have to persist data as it's processing it. What it'll do is it processes messages in a transaction, and it uses the delivery guarantees of the sources and sinks to guarantee delivery with crash resiliency. And it means that you can crash Benthos and you can destroy the machine that it's running on, and you can corrupt the disk that it's using, and you still get at least once delivery guarantees. It doesn't change any of that. And with this architecture also comes tight back pressure. So if the outputs become unavailable for whatever reason, Benthos will just gracefully stop consuming messages, so it doesn't just fill up the memory on your disk, and then subsequently when the outputs become available again, it will just gracefully start processing messages. And this is what the architecture looks like. Roughly, we've got it split into 3 sections. The first one is inputs, where we're consuming data. And what happens is, depending on the type of the connector we're using, messages that we consume, we wrap them in a transaction which contains within it a mechanism whereby any other component within Benthos can propagate an acknowledgement or a NAC, an acknowledgement back to the source itself. So in the case of Kafka, what happens is an offset is never marked to be committed until the transaction has made its way all the way through the pipeline and something has acknowledged it. Then we're able to commit that particular offset. And then what we've got in the processes layer is we can just have any number of threads executing the processes that we've configured, and they just perform mutations on the messages. And then finally, we route the transaction to the output layer, where the output layer is responsible for making sure that the message gets routed and successfully sent to every single output that it's supposed to be sent to. And only when that has happened does an acknowledgement get marked ready to be dispatched upstream. So if you've got Kafka, then like I said, it would mean that the offset of that particular message will now be marked ready to be committed. But if we were hooking up with something like Nats or RabbitMQ, then we would propagate the acknowledgement upstream. If something goes wrong, then Benthos will not just drop the data, it will continuously. So in the case of Kafka, where there's not really a concept of a NAC, we can't reject the message upstream. What will happen is we'll just keep trying that message with back pressure until it's successfully delivered. But if we were using something that does support NACs, then we would just send the NAC upstream, unless you've told us otherwise in your config. Now, you might not always want that. Benthos's default is to never drop messages and just continuously retry, but if you want to do something else, then you are completely welcome to do that, and you can do it with config. So there's a bunch of different components for expressing exactly what you want to happen. One of them is a try broker, where you can specify any number of outputs, and basically Benthos will try the first. If that fails, then it will move on to the next, and so on and so forth. So you can kind of use this to create dead letter queues or fallback outputs in case one becomes unavailable or just cannot process a particular message. But also, if you wanted to do something like just drop the data in that case, obviously it's not recommended, but it's completely up to you to do that, and there is a specific output for that. But you have to make it explicit, basically, is what I'm saying. Benthos won't just drop things because it couldn't deal with it. Similarly, you might be looking at the processors. So for example, executing Lambda functions or interacting with caches and things, that's obviously stuff that can fail. So like I said, Benthos doesn't just drop that data because it couldn't be processed. What happens by default is if processes fail, then the message is, it has metadata attached to it that describes the fact that a fault has occurred and what the fault was. But if you don't tell Benthos what to do with that failed message, it will continue to send it downstream. So it doesn't just drop the data. But obviously that's usually not what people want. You want to have some sort of error handling depending on what your use case is. So the super common one for people who don't really care about their data that much is to just log the contents of the message and what the error was, and then just drop it. So that's what that would look like. You put it within a catch processor, which has child processors that are only executed if a previous processor has failed, and yeah, you just get rid of it. Or you could do stuff like route the failed messages to a particular output. So again, kind of you're basically doing a dead letter queue again, but in this case with respect to processes that have failed. And this is the switch broker that I showed you in a previous slide, where you can have a condition on one of the outputs where if the message has failed in any of the processing steps, then you'll route it to a particular output. Otherwise, you route it to your main output. And there's a bunch of different patterns. There's a bunch of different things. They're all documented on the website. But basically, by default, nothing gets dropped. Nothing just gets deleted. Benthos will try and deliver everything that passes through it, and then it's up to you to kind of decide when things perhaps should get dropped or when we fall back on other plans. Another thing is unit tests. So obviously in a declarative config, just because it's declarative doesn't mean you don't have business logic in there to some extent, especially with things like mappings, and Benthos supports unit test definitions that you can affiliate with a particular config. And this allows you to specify some sort of input message to feed in, and then you specify predicates to describe what you would expect to come out, and then you can execute those unit tests with the test subcommand, and that way you can kind of block your deployment pipeline on those tests just to make sure you haven't regressed in any of the behaviors that you expect. So Bloblang, so I've already shown you some snippets of Bloblang in Benthos configs. Bloblang is the Benthos native mapping language. So Benthos supports JQ as well, and James Path, and some other mapping. You can also just script your own sort of mappings, but Bloblang is the sort of native one. And the purpose of Bloblang is to be readable and maintainable, and allow you to dig into these large structured messages and do some manipulation to them, but also it's not horrible to look at. It's kind of similar to JavaScript, I guess. So I've got an example mapping at the top to demo, and here's an example input being fed into the mapping, and this is what the output would look like on the bottom. And I'm just going to go through this line by line to quickly give you a run through of the syntax. So the way it works is with assignments where you're building a new message. And root on the left-hand side refers to the root of the new thing that we're creating, and you can create fields on that with these dot paths. And then on the right-hand side, this refers to the root of the input context, which starts off as the root of the input document being fed in. And here, this bracketed expression is what's called a coalesce operator where you can have any number of pipe delimited field names, and basically the first one that exists in the input document and isn't null will be selected. So because we don't have an author field in our input document, but we do have user is what gets selected. Then we select the ID field of that, and then this .string methody looking thing is a method, and methods are the main way that you do value manipulation and mutations within Bloblang. So this one is a type coercion. So whatever the type of ID is, it's going to be converted into a string. So as you can see on our input document, it's an integer, and on the output, it's now a string. Now this is a slightly more interesting mapping. So we've got an input field thoughts, which is an array of strings. And what we want to do is we want to copy thoughts over into the output document, but we want to filter out anything that doesn't contain the string Hall and Oates. So the way that I've done that is I've called a filter method on thoughts, and when you call filter on an array, it executes a little lambda mapping on each element, and if the mapping returns true, then it remains in the output array, otherwise it gets taken out. So what I've got is I've got my little lambda here that calls on each string, so each element we call contains to see if the string contains a substring, and I'm seeing if it contains Hall and Oates. And then as you can see, there was only one thought in the input document that concerns Hall and Oates, so that's what ends up in our output document. Now finally, I'm populating a new field called has good taste, and this is a Boolean. And the way that I'm populating that is I've got a static array here of Pokemon names that are lowercase, and these are Pokemon that have been predetermined to be lit. And what I do is for every document I call contains on that array, and I provide it the input documents fave_Pokemon, and I lowercase that so it's a case insensitive search. So basically for every document, if the input fave Pokemon is represented here, then we say they have good taste, otherwise has good taste is false. And as you can see, their favorite Pokemon here is Rattata, which is a trash Pokemon, and therefore has good taste is false. Now I would say that this mapping could be improved, because as you can see in our input document, we can actually look at one of their thoughts here, and that thought is that this person's favorite Hall & Oates album is H2O. Now, as we all know, that demonstrates very good taste. So even though their Pokemon knowledge is obviously not up to scratch, perhaps what we should have done is we should have also consulted the thoughts of a particular user to determine whether they have good taste or not, because really I think it was a bit of an injustice that this person has been flagged as having bad taste. And this is mostly, so as a language, Bloblang is kind of optimized for digging into real nested, nasty documents, big structured things, and pulling them out into all kinds of new forms. And this is an actual real world example. This is something that I use Benthos for. So I scrape the download statistics from the GitHub API for Benthos. And what I get back is an array of objects for each release, where it has a child, which is also an array of objects for each asset. And what I want to do is I want to pull out into just a single dimensional array containing the tag artifacts and the download counts. So this is a real Bloblang mapping that I actually use. I'm not going to dig into that line by line, but there's stuff like regular expression, replacements, and a bit of trimming here as well. But it's mostly just on a bit of filtering as well. But it's mostly just manipulating objects and arrays. And this is what I get out. So it's just an array of objects now, and it's much easier to work with. And this becomes especially useful when you're doing things like enrichments. So you might have big structured documents, and then you need to interact with all these different services in order to execute enrichments on that data. And inevitably what that will mean is you need to do a bunch of deeply nested document manipulation in order to turn that into something useful. And you can also feed it total garbage. So what I said at the beginning about Benthos is that it's quite unopinionated as to what you're processing, and that includes binary data, and that is also the case with Bloblang. So Bloblang is normally used to like I said, process structured data, but you can also just feed it total garbage. So here's a great example. What I've done is I've created an XML document, and then I've base64 encoded that, and then I have added that base64 encoded string to a JSON document, and then I've hex encoded that, and that's what you can see here. So this isn't valid JSON. This is just binary data basically. It's just raw bytes fed into a Bloblang mapping, and you can still process this with this mapping here. So I'm not actually going to execute it here. I'll leave this as an exercise to you, the viewer, if you want to run this, but it does work. Basically, we can just reference the input document by its raw bytes with the content function, and then we'll call decode on that, or hex decode it. Then we parse it into as JSON into a structured form, and then we can access the field XML document of that, which is a string, and then we can base64 decode that string, and then we can parse that as an XML document, and then finally I can start accessing the fields within the XML document. Total garbage. Hopefully you won't ever have to do something like this, but you can. And Bloblang's, you can execute this, it's quite convenient, you can execute it from Benthos itself. So Benthos has a subcommand blobble where you can run a Bloblang expression, query, whatever you want to call it. Similar, I guess, to how you would do JQ, but obviously it's not as terse as JQ is, so it's not going to be as tidy in a CLI environment, but you can use it for that if you want to, if you're a Bloblang expert. There's also a cool command, Benthos blobble server, and what that'll do is it will run Benthos as a kind of web service that hosts an app, and it looks a little bit like this, where you can paste in an input document, start building a mapping, and then you can see a live view of what the result of the mapping is. And you can also use this to edit existing mappings and things, so it's quite convenient. So you might be wondering at this point, who is Benthos for? Is it for me? And yeah, it basically is. It's for anybody who finds it useful. I see people of all walks of life making use out of it for all kinds of weird things. But it's primarily, I would say, for it's obviously in the data engineering space, so that's usually what it gets picked up for. And people in that space, you might have heard of data scientists. I've met a few in real life. This is what they tend to look like, but obviously your mileage might vary. And the reason why data scientists particularly like this as a tool is obviously most data scientists are more than capable of writing code and maintaining a code base, but why bother? It's not your core competency, it's not what you want to be spending most of your time on. So if there's a tool that you can just deploy without having to write or build a code base, then that's obviously going to be a win in a lot of people's books. But because it's got this nice declarative configuration, even though you're not writing code, you can still dig into the data and get it to do some cool stuff. It's still quite powerful. And obviously data engineers themselves might also want to use this. So I would actually say the majority of Benthos users are probably people who would consider themselves data engineers, or they're people that I would consider to be data engineers. So these are software engineers. They can obviously write and maintain their own code bases. But there's still a lot of reason why you might want to deploy something like Benthos. So you can actually write plugins for Benthos quite easily and compile those into your own custom build. But a lot of data engineers will just run it as it is out of the box and use the components that it's got with it. And the main reason for that is if it's solving all the boring tasks that tend to be your day-to-day jobs, then why not deploy something to do that? Rather than building it yourself, because that then frees you up to build cooler things and the real special sauce of your organization, rather than just focusing. Most of the stuff that Benthos does is just boring plumbing and hooking up various components, and it's not particularly interesting work. I think it's what most people don't want to be spending their time on. So if you can offload that to some other tool and focus on the fun stuff, then why not? And obviously this is what a typical data engineer looks like. I consider myself a data engineer as well, to an extent, and this is what I look like. And that's pretty much what I was going to cover in this video. That's a rough overview of what Benthos is. If you want to dig into more of what it is and what you can do with it, there is a website, conveniently, that describes all of the goodies that comes with it, and documentation for all the various component types. And you can find that at www.benthos.dev. I'll put a link in the description as well, if you're exceptionally lazy. And there is a community. If this looks like something that you might be interested in and you're looking to hang out with like-minded people, then you can find us at, there's a bunch of links on benthos.dev/community, and that will give you links to the Discord group, which is my recommended place to come and hang out. There's also a Slack channel on the Golang Slack, and there's also some other links, so you can find me on Twitter and stuff like that, but you can also find me in person. And that's it. Thank you for watching. Hopefully you found that interesting. Good luck on your Benthos journey if you decide to go down that route. If you like this video, then there's a digital way of expressing that, which is there's a like button on the page, and there's also a subscribe button if you don't want to miss out on future videos.